Hey, good morning, everyone. Welcome to Whitmix's webinar, 3D Printing Digital Dentures with Dentca Resins. This is part one of a two-part series. I'll tell you a little bit more about part two in a little while. My name is Bernie Jaroslaw. I'm the marketing manager here at Whitmix, and I will be facilitating the webinar today. I'd like to begin with a few housekeeping items. First, you should see a question box on your screen. Please feel free to type in any questions you might have throughout the presentation. Cory will be answering your questions at the end of the webinar. Next, if you're a CDT, this webinar is approved for 1 hour of CE credit toward your recertification. You'll receive an email within 48 hours, and it'll explain exactly how to get that credit. Lastly, this webinar is being recorded. So within about 48 hours, it'll be up on the Whitmix website in the webinar section. So if you've missed any of this or have anyone else in your laboratories that would like to see it and get credit for it, that can be done in about 48 hours. This morning, I have the pleasure of introducing Cory Lambertson. Cory is a technical services rep here at Whitmix as a certified 3Shape, Roland, and a Sega trainer. He develops and conducts CAD/CAM equipment and software training and provides technical support and assistance to our digital customers. Before joining Whitmix, Cory worked for 2 years in his father's dental lab, Heartland Dental Laboratory, in Hillsdale, Michigan, as a 3Shape CAD/CAM technician. Cory received his Bachelor's of Science in Finance from Andrews University in Berrien Springs, Michigan. So today, Cory will be speaking on 3D printing digital dentures using the Dentca Resins. The digital denture is finally growing into its own. There are a lot of questions that labs ask about the manufacturing process, so this webinar is intended to cover the basics of implementing the first FDA-recognized digital denture materials. Cory, Whitmix's 3D printing guru, will provide you with all the information you need to know to start utilizing the Dentca Digital Denture System in your lab or dental office. Now, the part two is a little different in that Cory will show how to design a digital denture to be 3D printed using 3Shape dental system and a Sega 3D printers. In part two, he'll cover design and share printing tips for the Dentca photopolymer resin process, and it'll also cover how to properly post-process to achieve the ideal digitally produced denture. So that happens a week from today, or is it 2 weeks from today?
Yes,
2 weeks from today,
yeah.
Sorry, on that Tuesday. So without further ado, Cory, tell us about digital dentures and the Dentca system.
Awesome. Thank you so much, Bernie. I truly appreciate your intro as always. So today, everybody, we're going to go ahead and we're going to start off with just introducing Dentca itself and covering who they are, what they are. From there, we're going to jump into the actual system, what you need to have to be able to print with the Dentca Resins itself. We're going to cover some of the 3Shape order form creation, and then from there we'll cover the printers and how to post-process the prints. So this is a jam-packed session. Feel free, if you have any questions, write them down, send them over, and we'll answer those at the end, of course. All right. So let's see here. So who is Dentca exactly? Really Dentca, we didn't really hear of them or really know that much about them until about the last year itself. Maybe even a year and a half ago, I think I saw an advertisement come up and I was like, oh, this seems like a really cool process, but we just weren't really there yet with the 3D printing technology. At least we didn't believe it at that point. So who is Dentca exactly? Well, let's just put it plain and simple. They are actually the world's first digital denture CAD/CAM company. They're the first to create a digital denture software, and they were the first to have a 510K FDA cleared Class 2 3D printable denture resin, which is most likely why you all are listening in today to learn more about the resin itself. More about Dentca, they're actually based in beautiful sunny Southern California. And also, they really pioneered the path for CAD/CAM digital dentures. They have a full impression tray system and CAD software package where they can design for you. You can have a complete final denture in as little as 2 patient visits needed, 3 patient visits needed if you use their try-in service, and you can have this completed in a little under 3 to 5 business days, which is impressive, especially considering the traditional denture method would at least take a minimum of a month to go from start to finish. So let's learn about some of the history of Dentca itself. They actually began in 2007. They was actually established by a total of 7 dental professionals that all came together to develop a process to produce a final denture through CAD software, solving problems that are inherent to the conventional denture manufacturing process. So they all had an idea of how we needed to streamline denture manufacturing, and they ran with it. So in 2008, they actually initiated an IT team and started designing the software and integrating a tray system with it. By 2009, Dentca is incorporated, and US and international patents are filed. The Dentca device was deemed successful and ready for production. The Dentca device is the tray system. I'll highlight on that a little bit later. In 2010, the world's first 3D denture design software was finalized, and it moved on to field testing for commercial launch in 2011. Now in 2012, it was released, and they received the Pride Institute Best of Class Technology, and they also received the US patent granted for that CAD/CAM technology itself. Now in 2013, I put this in bold. This is extremely important. They created a partnership with a company called Mitsui Chemicals. That is actually part of the manufacturers that create this denture resin itself. It's one of the mother companies. With that, in 2013, they created the adjustable 3D printed try-ins process in their software, but most importantly was that merger with Mitsui Chemicals. By 2014, the US market expanded and international market penetration was initiated. And then by 2015, they had their complete FDA approval process cleared at that point in time, which is super cool. Now, 2019, I had to add in this extra little tidbit. This is actually where Asiya and Whitmix and Dentca all collaborated together to qualify the denture resin with the Asiya line of 3D printers. So this is something that Whitmix worked extremely hard on, and it took about, I just spoke with our project engineer, and she stated that it was about 3 months of working with this project, but to me it felt a little bit longer. I want to say it was almost a year from start to finish, from the first communication point with Dentca to when it was actually released. So Dentca, they are more than just a resin manufacturer or producer. They actually have a full CAD/CAM service that they offer. So you can actually send files to them for them to design for you, and then they can send back the final indication for you to either mill or 3D print. So those offerings that they have what is known as the Dentca 4, and this is a mill-only option, so the resin doesn't apply for this. There's actually, if you look at the photo on the bottom of my screen, this is actually a segmented hybrid implant bar system that they integrate with a zirconia Pretal style bridge on top of it. So it's a super cool technology that actually eliminates the need for using multi-unit abutments, bone grafting, or dealing with the challenging bar fitting planning process. After that, they offer a Dentca temp system, which is for it's segmented making for custom temporary for chair side indication, where you can actually mill it in-house. You just have to send them the scans. And then they offer the Dentca immediate design solution and the Dentca 3D printed denture design solution. For that, they can send you back the files for which you would utilize that the denture resins from Dentca to print in your 3D printer itself. Now, besides the CAD/CAM services, they also have an impression tray system, the Dentca system that they offer. This accurately captures the vertical dimension and the centric relation, and by all-in-one tray system. Included with that tray system, it actually implements the impression tray, arch attachment for an easy tracer, a jaw gauge, a lip ruler. And if you use this tray system combined with their design service, you can actually achieve that 2 to 3 patient visits at the doctor's office, which is super cool. And then, of course, beyond that, they do offer the printable denture resin, which we'll cover here in a moment, all the offerings they have for that. And then they have a service where you can become a Dentca Partner Lab. So you can be a recognized Dentca Partner Lab, which is a super cool feature. So if you are getting into printing with the Asiya 3D printers and using their resin, I would definitely recommend reaching out with Dentca and becoming a part of their system there as well. So the Dentca Denture Resin, let's go ahead and cover this. It is a FDA approved, cleared Class 2 medical device or medical resin that was developed in a similar way using a similar type of acrylic to PMMA. It's actually methyl methacrylate, which is MMA, replicating the similar properties of a traditional denture. So they have 3 different types of denture resin. The very first type that they have is the Dentca Denture Try-In Resin. The retail price on this denture try-in resin is $350, and with it you get 1 kilogram of resin. The purpose of the try-in resin is to immediately try in a designed denture that was fabricated before deciding to make your final denture. So it gives the doctor the ability to go ahead and make adjustments to the try-in denture, and then you can either scan it back in and design to that in whatever software you're using, or you can decide that this is exactly how I want my design to be, and you can move on to the final production of the denture itself. The try-in material is not used for long-term. This is not the long-term material. That would be the denture base and the denture teeth material we'll cover here in a moment. 1 kilogram produces about approximately 20 arches of the try-in material, and it only comes in ivory in color. The Dentca Denture Base Resin, that retail price is $380. For this is for the manufacturing of the actual denture base, so the tissue colored material. You can actually remove, or you can produce full dentures. They also advertised as removable partial dentures, and of course manufacturing base plates with this material. In 1 kilogram, you get approximately 25 denture bases out of it, which is actually a pretty good number. And they have 4 different shades of this. They have original pink, reddish pink, light pink, and dark pink for their denture base material. Moving on to the Dentca Denture Teeth material. So for this is the most expensive material. The retail price is $435 for that denture teeth material. It is, of course, for the use of 3D printing the actual teeth itself. And you can actually lute the teeth to the base in a process that we'll cover here in a little bit. 1 kilogram of this material produces approximately 50 arches. And of course, then it comes in the Vita shades of A1, A2, A3, A3.5, B1, and B2. So the general workflow for 3D printed dentures is actually we have to start at the impression taking stage, or if you have a cast and a wax rim, you'll start there. From there, you're going to scan that data in using a desktop scanner. After you scan the data in, you're going to work into the design workflow. You're going to design your either denture try-in or your final denture. The denture try-in, if you use the Dentca system, it is optional. They have really high success rate actually bypassing that denture try-in and going straight to the final denture if you use their exact workflow, which is really impressive. If you're going with like a design service like through 3Shape or ExoCAD, I would recommend to start off with the try-in denture option first, making sure that your design is appropriate and aesthetic the way you like, and then move on to redesigning and producing a final denture, printing the base and the teeth separate. So the general workflow is you have to start with that impression or cast, scan it in, design it, and then 3D print your final restoration. So the digital equipment needed to get started for the Dentca system itself, I'm going to highlight, there's two sections here, the 3D printer and the post curing unit. That is a must. You have to be within these guidelines for using the Dentca resin itself. But if we start at the top, for desktop 3D scanning, of course, we're going to recommend the 3Shape desktop scanner. We believe it to be the best on the market. There are others that you can use. You do not have to use the 3Shape desktop scanners. We have a lot of friends, or I know a lot of people that are fans of ExoCAD. So if you're using ExoCAD, you can use, Degree of Freedom, Medit, Shining 3D. There's a number of desktop scanners you can use to get into using the Dentca resins. For the denture design software, of course, I believe 3Shape Dental System has the best hands-on design software for dentures. ExoCAD has a denture module. I've not used it yet, so I have limited experience on that, but from what I hear, it is a good software. And then, of course, Dentca Design Services, they have their CAD services, which I believe is awesome. And then, of course, you can use an outsourced partner. So that'd be like using like Full Contour or another company to do your designs for you. After you have your case scanned in, designed, we're gonna move on to that 3D printer. And so there's a number of 3D printers that are actually validated with this process. Of course, the Asiya 3D printers, Dentca has partnered with a company called Zenith for their 3D printer. Moonray is also validated, and of course, Carbon 3D has a partnership with Dentca as well for their resin. Now, these are the 4 3D printers that are validated for this Dentca resin. If you were to use another printer outside of those 4 that is not validated by Dentca, then you are not going to be covered under that FDA compliant process of the 510K. Of course, that same theory goes with the post curing unit. You have to use one of the supported curing units that was validated by Dentca. So we have Uvatron, Dymax, Electrolyte, Hummel, and then Dreve. They all have, these are all acceptable curing units with the with the Dentca resin. You can actually capture all of this information if you were to go to our website, whipmix.com, go to our 3D printing page, and if you locate the Dentca resins on our page, on the right-hand side, there's instructions of use for each material, the try-in, the denture base, and the denture tooth shade material. If you select, or if you find the instruction of use, you can locate all of these requirements that you have to fall within to be able to be under that 510K umbrella to use the Dentca resin. So the Whitmix validated process, I wanted to show everyone what all is available to use for the Dentca resins, but this is really what Whitmix validated in that year-long process with Dentca. So, of course, we are resellers for the 3Shape desktop scanners. This is what we actually use for our design process here for validating the resins and validating the printers with it. It's going to work with all of the current scanners, the E1, E2, E3, E4, and D2000 scanners. And it also does work with the previous generation scanners. So if you have an older D700, D800, even older than that, you can still use those scanners to design or to scan in your wax rims or impressions to design your digital dentures from that. I do have a recommendation. It is ideal if you have a scanner that has the textured scanning ability. So either in black and white or full color. The reason why I recommend that is that you have the ability to draw on the cast, make any sort of markings you want. Or of course, when you're scanning in your try-in denture, if the dentist was to put any markings on that, or if he was to add any sort of wax in another color to help differentiate his changes that he wants, you're actually going to be able to capture that in the scanning process and view it accurately, which is extremely important when you're trying to redesign a try-in denture for your final denture in the 3Shape software. For the actual design software, under 3Shape Dental System, of course, we have the 3Shape removable packages. This 3-shape removable package gives you access to designing custom impression trays, which you can also use that module to design a simple base, denture base. You have, of course, the full denture module and the RPD, removable partial denture module under 3-shape removable. Under complete restorative, you have the ability to, of course, have access to all of the modules. That is the complete package. And you can, if you don't have complete restorative or 3-shape removable package, you can add on the full denture module to achieve the denture design software. And you can also purchase CAD points to denture or to design dentures as well, which is really helpful if you don't want to make that commitment into that large of a purchase right off the bat. So the Asiya 3D printer and the Dentca denture resin and the Uvatron curing unit, these are the 3 must-have if you're going to be using the Dentca resins with our process that we validated. So under the Asiya 3D printers, the 2 validated printers today is the Sega Max UV 385 and the Sega Pro 2 UV 385 nanometer wavelength printer. So those 2 printers, when we started the process, those were the only 2 Asiya printers that had a large enough build plate to reasonably print denture bases, denture teeth, and the try-in denture materials. Since then, this last IDS, Asiya, of course, released the Sega Max LCD, the Pro HD, and the Pro 4K, which the Pro HD and the Pro 4K replaced the Sega Pro 2. So from here moving forward, we're actually in process with getting those 3 new printers added to that umbrella to be able to use that Dentca resins for printing dentures. So that we should have released here shortly. Of course, the Dentca denture resin, and then the Uvatron UV curing unit is the final process to complete that 510K. The Uvatron curing unit, right now, I believe the cost is around $4,000. I just heard this morning there's actually a newer, lower cost unit coming soon. So be on the lookout for that. We're shooting between June and July for a release date on that curing unit. So I want to jump into the 3-shape denture design options for 3D printing. So this is actually a screenshot of the inside the control panel of Dental System 2019. A lot of questions I get when we have people that are switching over and starting to use the design software for 3D printing dentures is that the naming convention for the denture selection or type of dentures is actually kind of confusing in 2018 and previous versions. So in 2019, they actually cleaned up the naming convention for designing dentures. And so there's a total of 3. I'll explain each one. So there's monoblock that can be used for 3D printing. There's base with design teeth, which is used in 3D printing. And then base with artificial teeth manual reduction is used for inside of 3D printing. And then the last one says milled with artificial teeth, milled reduction. That is actually part of a milling process. So we're not going to go into that since we're not supplying any materials for that option at this point in time. So injection molding, this is actually the original name. It's being renamed to monoblock in Dental System 2019. So it just makes sense of what monoblock is. It is one monolithic denture. This actual option is going to be used for when you're designing a try-in denture. This can be milled or 3D printed. Of course, 3D printing is going to make a lot more sense due to the amount of time it will take. I printed some try-in dentures just the other day, and it took, I want to say it was about 1 hour and 10 minutes for 4 try-in dentures on a Sega Max, and that was in 100 micron layers, which is awesome. We'll cover that here in a minute. But this actually exports out a single design file of the denture and denture base and the teeth together, and it's going to be used for a try-in for your patient to see if it's if they're aesthetically pleased and if the form and function of the denture is there. You are going to 3D print this in the Dentca try-in resin material. And just to see how to create the order form for this, I took a screen capture of this. It is extremely important. Of course, select the teeth that you want for the denture base or for the denture itself. Over on the right-hand side, you're going to select gingiva. And then on the green plus sign, I want you to select as the material, as model material, and then the type will either be injection molding if you're 2018 and previous, and then when 2019 comes out, you're going to use monoblock as the option. Now, you may be kind of confused on why I selected model material. The reason why you select model material is because that's going to tell the 3Shape software that this base and the teeth combined, you can see up on the top also I added under anatomy, the artificial tooth type is model material. Those teeth combined to the base, when I choose model material, the software knows it's going to be 3D printed. So it's going to export it out in a single STL file. If you do not use this option under model material, it actually cuts the STL file into like multiple layers. And it's really kind of frustrating the first time you go into design and you export out your STL file. So of course, you know, just a tip, make sure you're choosing model material for this. And to have it be one monolithic piece as a tri denture, you're going to choose monoblock or injection molding under the type for the denture. The next type of 3D printed denture option inside of 3Shape is going to be glued in teeth arch. And this is going to be renamed base with design teeth. It just makes sense now. Base with design teeth. It is exactly what that is. You are going to have a denture base, and then it's going to have custom designed teeth that are going to be glued to the base itself. So just a tip inside of the 3Shape control panel under the design options for denture, if you're going to be using this this option and designing your base and the teeth separately and glue them together, if you want to have full morphing capabilities of the actual teeth themselves, then I would make sure you enable the teeth freeform design option in the control panel. This gives us the same functionality that you get with all the crown and bridge modules of having the morphing tools and scaling tools of the teeth. So it makes it a little bit easier to design or transition from a crown and bridge workflow to that denture workflow if somebody's already used to designing in the crown and bridge modules. Now this is going to export the denture base file and the denture teeth file in two separate files. 2018 and previous, it only allows the teeth to be exported out in one full arch. So for some of the smaller base plate or build plate 3D printers, printing that full arch really limited your space. In 2019, they are allowing you to block the teeth for anterior and posterior. So that's really going to help out that workflow and being able to squeeze as many indications or many sets of teeth on that build plate as you can for that production laboratory. And of course, for this, you're going to print the denture base in the Dentca Base 2 resin, and the actual denture teeth are going to be printed in the tooth shade material. So how do we set up this order form? It's kind of similar to what we had before. You're going to select the teeth you want for your denture. You'll go over and you'll select gingiva, and then you'll go over to the green plus. You are again going to select model material, so that the software knows you're going to 3D print this denture base. And then you're going to select the type as base with design teeth, or if you're in previous versions, is glued in teeth arch. From there, you're going to go up and select on the anatomy button, and then select on the artificial tooth option all the way to the right. When you do that, you're also going to make sure you change the artificial tooth material type to model material. Once again, that's going to tell that the teeth are going to be printed out as in a 3D printing method. And then also, of course, if you want to bridge the teeth together, you'll go ahead and you'll just select on bridge option, and that's going to bridge all the teeth together. Remember, in 2019, you do have the ability to block the teeth together in separate sections, so anterior and posterior. And the final option for 3D printing inside of 3Shape into previous 2018 is called glued in teeth manual reduction, and the new 2019 is going to be renamed to base with artificial teeth manual reduction, which it just once again makes sense now. For this, you're going to use for designing a final denture with pre-manufactured teeth to be glued into it, so carded teeth, stock teeth that you bought from your, I guess, denture tooth library provider. For that, just a little tip, if you are going to be using stock card teeth in the design software, make sure you do not have that free form option enabled. If you have that enabled, you can accidentally skew or scale the teeth. which then your carded teeth and your designed teeth will not be the appropriate sizes. They will not match, which will cause an inaccuracy. So for this, you're going to print out the base, and then you're going to manually adjust the teeth until they fit properly into the base itself. This design process is only going to export out a denture base file, and then there is an option inside of 3Shape. If you enable it in your dongle, you can create a placement jig that you can actually place the carded teeth into, which helps with the orientation and mating process to the denture base while you manually adjust the bottom of the teeth out. And of course, you're going to print the base out in the Dentca base resin. So the order form for this is you're going to highlight the teeth you want for the arch. You'll go over and select gingiva. On the right hand side, you'll go to the green plus. You're going to choose base with artificial teeth, manual reduction, and of course you're going to select the model material option as the material type to tell the software it's going to be for 3D printing. And then of course up at the top under anatomy, you're just going to select anatomy. It's going to default to the artificial tooth type. And if you have a specific library, let's say from like Ivoclar that you're using or Colzer, you would go to the green plus and you can choose their exact option that they uploaded in their DME file for you. So we just covered quite a bit of information about the 3Shape process. Now remember, I'm not actually going to dive into design today. That's going to be in the part 2, just because the design process is going to take up a full webinar session. So we're going to move on to the Asiya 3D printers, and we truly believe they are repeatable, reliable, and the best proven dental 3D printers on the market, and it is trusted globally. We have partners across the world that we speak to on a regular basis that are resellers for Asiya, and they vouch on how awesome the printers have been for them. So the technology of the Asiya 3D printers, they are a DLP style 3D printer itself. And so how this works is there's actually a DLP projector in the bottom of the printer, and it's going to project up an image that is going to cure to the build plate from the photopolymer vat itself. Inside the vat is where you're going to place the denture resin or the two-shade resin or the try-in resin. We do recommend having a separate resin vat for each resin you're using. I have a separate webinar that covers a little bit more in depth on 3D printing technology itself. It's called 3D Printing Tips, Tricks, and Hacks. I will be giving that seminar here in Lab Day West this upcoming Saturday. So if you're going to be at Lab Day West, feel free to stop by and we can talk more about the 3D printing process and a little bit deeper dive. I just want to show this though, just so everybody's on the same page of what the technology is. So to cover the 3D printers, the most recent 3D printer that Sega has released is called the Sega Max LCD. The technical specs behind this, most importantly, this actually isn't a DLP printer, so I don't have an appropriate slide to depict exactly how it works. But what it is it has an LCD panel right at the imaging plane, and when the light shines through, the LCD panel will open or close the pixels to allow the image to shine through. This is actually a great entry-level printer for anyone that's wanting to get into 3D printing and is new to 3D printing. It's not going to be the workhorse that we see in the other 3D printers. It's not going to be as fast as the other Asiya 3D printers. For this printer, though, you can fit approximately 3 denture bases on it. It has an XY pixel size of 47 microns, which is extremely accurate. Z layer resolution, you can go down to 1 micron layers. It has a wavelength of 405 nanometers. And when I was in IDS, when I was speaking with Asiya, with Evan Kemper, they were actually talking about possibly making it a 385 nanometer option, which would be awesome because this would be the first LCD 3D, or one of the first LCD 3D printers in this compact form that allows for 385 nanometer light source. Also, I believe once this is validated with Dentca, this would be one of the first LCD style 3D printers validated with the Dentca process as well. All the Asiya printers are a true open source material 3D printer, so you can use any material from any manufacturer, so you're not just stuck with using the Dentca resins or Whitmix resins. You can use resin from any manufacturer. And of course, one of the coolest features that all of the Asiya printers have, it has an internal radiometer, which is where the actual tool that measures the light intensity at the image plane, it actually feeds that intensity back to the software to calculate the proper exposure time, print after print, even as the actual LED lights start to degrade. The retail price on this is $6,990, and we're looking to start shipping these about July as the last date that I've heard. The next printer, this has been the workhorse as of late. This is the Sega Max UV. You can see in the photo, it shows that they printed, or Sega printed 6 denture bases on this Sega Max. Now that I've tried to fit 6 denture bases on this printer, I gotta be honest, it's a little more challenging. So this photo is slightly misleading. Realistically, about 3 to 4 denture bases, and the reason why I say 3 to 4 is because in the real world, those denture bases are actually slightly larger than what we have in the image here. With those denture bases, you can print the denture bases vertically in 100 micron layers on an Sega Max UV in about 1 hour and 10 minutes, which is extremely fast. The build envelope is 119 by 67 millimeters, and the native XY pixel is 62 microns. Now this shares the same layer resolution as the other printers of, you can go down to 1 micron layers if you wanted to, and it comes in a 385 nanometer wavelength light source. And of course, this has the internal radiometer, which I believe is one of the coolest features of the printers. And the retail on this is $10,990. They actually just dropped the price after releasing the new printers. It was $13,990, and they dropped it down to $10,990, which is an awesome entry point. This has been a workhorse printer for us here at Whitmix. We sell quite a few of them, and everybody is extremely happy with the printers. Beyond that, we have the Sega Pro 2 75 printers. So the Sega Pro 2 series, this has actually been discontinued, but I have to include it in the slides because this printer is actually validated with the Dentca resin process. So it's under that 510K umbrella. The tech specs on this has a larger build plate than the Sega Max. So it's about 144 by 81 millimeters. And you can fit approximately 6 denture bases on this printer. So the Sega Pro 2, you can easily fit the 6 dentures vertically on that build plate. The XY accuracy of this is 75 microns. And once again, it has the same information as the last 2 printers of 1 micron layer, down to 1 micron layers, the 385 nanometer light source, and of course, true open source material in the internal radiometer. This printer has also been a workhorse for us, but we're really excited for what is next to come. So they've discontinued the Sega Pro 2 75. It used a little bit of an older technology. It's not as fast as the new printers are, or the Sega Max is. We can print those 6 denture bases on this printer in 100 micron layers and realistically about that 2 to 2.5 hour mark. So it's not as fast as what we see on the Sega Maxes. Now the Asiya just released the Asiya Pro HD. So this printer is a significantly larger build plate. You can fit approximately about 8 to 10 dentures on this printer here, and you can print those dentures in about 1.5 hours in 100 micron layers. So it's extremely fast, a huge increase in speed from the old Asiya Pro printers. We're extremely excited for this printer to get here. So the new next 2 printers I'm going to show you, they are actually going to be here. Realistically, I've heard about June, July. That's what we're shooting for, possibly in August as well. It all depends on how soon we can get one in and how soon Sega finally gets the validation process completed on them. We're really excited for these printers. So this has an XY accuracy of 80 microns. Build plate is 154 by 86. Once again, it's still, the other information is still the same as a true open source printer. And of course, it has that internal radiometer of being able to accurately feed and loop back that internal rating of intensity of light back to the software for that proper exposure time calculation. Now the retail price on this printer compared to the old Asiya Pro 2, the old Asiya Pro 2 is $24,990. This is actually dropped down to $14,990. So they did do a price restructure to stay competitive in the market. I'm really excited for this printer. I think we're going to sell quite a few of them, and it's going to be an awesome game changer for those labs that want to go into that digital denture arena. Now the next printer we have, this is actually the largest printer that Asiya has. It's a Pro 4K. ultraviolet. It has an 80 micron XY pixel, and it has a build envelope of 217 by 122 millimeters. It's actually about 3 times the size of the Asiya Max, actually a little bit bigger than 3 times the size of the Asiya Max build envelope. This you can print. I counted. I have a screenshot of what the gentleman there is holding of all the dentures that he has. It's approximately 18 dentures there, and that you can print in about an hour and a half as well. So this is the printer that we're going to see for those large production laboratories, or those laboratories that are expecting to have that boost in growth for the digital dentures. Once again, you can go down to 1 micron layers if you wanted to with the printer. It comes in a 385 nanometer wavelength, so you're going to have the optimal light source for all materials. It is a true open source material printer, and of course it has that internal radiometer to loop back to the software to calculate the exposure times properly. And the retail price on this, I was actually quite blown away. For a printer at this caliber and this quality, it's only $24,990. This is going to be an awesome printer. This is going to be a game changer for sure. So here's a screenshot, or actually a photo, up close photo of the build plate that that gentleman was holding. You can see on here, they actually squeezed in 18 dentures on this build plate and printed it in an hour and a half. This is just phenomenal. This is something that we're super excited to see come to the market, especially for laboratories that are really going to see that growth in that digital denture arena. So before we move on to talk about the curing unit, I want to cover some of the what Z resolution means and what XY resolution means for those that do not. Z resolution is how thick the layers are that are being printed. Now there's a trade-off when you change the layer resolutions for when 3D printing. So if I go with a thicker layer, I'm going to print significantly faster. However, with a thicker layer, I'm going to have a reduced surface quality. We're going to have more of a stair-step feature. So you can see the object on the left, that was printed in, let's say, 100 micron layers versus the object on the right was printed in 50 micron layers. The object on the right, because it has more layers, is going to take more time to print, but it's going to have a higher surface quality. So something that you should think about when you are starting to 3D print your dentures is also think about the post-process part of how we need to polish these layer lines off and how we need to pumice and remove those layer lines and adjust it so that you can't see those layer lines any longer. So what we've done, we've tried printing dentures in 100 micron layers, the denture bases, and for an economy denture, I find it to be awesome because you can actually polish it off away. You're not too concerned of really the looks, but you're more concerned about the actual form and functionality with that economy denture. But it just takes a little more time to actually post-process it. Now, if you're doing a high-quality denture, I'd print that in the 50 micron layers. You're going to spend less time finishing, and it's going to just have that little bit higher detail that you're looking for. Same for the denture teeth. I would print those in 50 micron layers. I would not print those in 100 micron layers. Tri denture though, print that in 100 micron layers, absolutely. Beyond Z resolution, there's also XY resolution, which I touched on briefly a little bit ago for each printer. The larger the pixel size, the actual surface quality changes. So you can see some of the pixelation. So we have 2 different prints here, 2 different objects that were sliced with different XY resolutions. But you can see the object on the left has a smoother surface quality to it. So if you purchase a printer that has a tighter pixel size, it's going to have a more I guess a smoother surface, an easier surface to finish down before or in the polishing process. If we go with an object or a printer that has a larger pixel size, you're going to spend a little more time, a little more extra effort with that final polishing stage. So just something to think about when you're in the 3D printing market and looking at different options you have. So the final process of that umbrella with the Dentca Resins is having a proper curing unit. So we actually teamed up with a company. It's a IntelliRay. This is a Uvatron curing unit, IntelliRay 600. This is actually the fastest curing unit that is part of that Dentca system. You can actually cure the dentures in 20 minutes. which is extremely fast. It has a wide range spectrum of 320 to 390 nanometer light source, so it's in a very intense light, and it actually has a very large capacity, so you can actually cure up to 12 dentures at one time, which is perfect for those laboratories that are looking to grow. Also, on top of that, it is a integrated cooling system inside of the curing unit to prolong the life of the components. So you're going to see this curing unit lasting longer than others. And it has a shutter exposer to the exposed shutter for the highest protection of UV radiation. So this is ultraviolet light that's shining. This actually has a built-in shutter to prevent any sort of external radiation leaking out into the laboratory, which is going to help keep you and your employees safe. And it has houses a 600-watt metal halide lamp. Now I did hear this morning that there is a lower cost unit coming, and once again we'll see that in June. So I'm really excited to see that option. So let's cover how do we post-process the Dentca resins. We have to cover, this is like extremely important. If we do not follow the post-processing requirements according to the instructions of use for each resin, you are outside of being FDA compliant. So you no longer have a FDA cleared device if you do not follow the process properly. So the whole cleaning process, and we're going to cover, I have actually 2 really nice videos that Dentca has provided us, and you can actually get it from their website, and you can watch that process again if you need to, but it covers how to stay in that compliant process. So cleaning the dentures, the first step you're going to do is detach them from the build plate, and then you're going to remove the supports using a flush cutter from the actual objects that were 3D printed. And then you're going to wash the printed dentures in isopropyl alcohol. It's extremely important to use isopropyl alcohol because that is part of that validation process. After you wash them in the alcohol and you deem them clean, you're going to remove them and let them dry. From there, you're going to move on to the post-curing process. So the final cure, or to cure the final denture, you have to do it in a glycerin bath with an approved curing unit. We covered that list of curing units previously in the presentation, so if you ever need to refer to this presentation, you'll be able to find the webinar at a later date once it's released. Also, if you go to the instructions of use for each material, it lists which curing units are validated for the Dentca resins. But you have to use a glycerin bath for some curing units, and the other ones, there are some that require nitrogen as well. So the final denture, if this was a final denture that we were going to cure, the glycerin actually needs to be 60 degrees plus Celsius. So you actually have to preheat that glycerin before curing. And then from there, once that temperature of the glycerin is at 60 degrees, you're going to place the dentures into the liquid glycerin. You're going to place a piece of glass on top of it, and then you'll place it in the curing unit for 20 minutes. You will want to flip it halfway through. That's for the final denture. And this is after you lute the teeth and the base together. We're going to see that process here in a moment. After that, we have the try-in denture. The try-in denture does not need to be used in a preheated glycerin bath, so you don't have to worry about that. And the glycerin itself, you need to replace it every 80 hours of use, just so you know what the lifespan is on that. After you finish curing it, doing that final cure, you're going to remove and wash the denture, and then you can move on to your polishing and pumicing and polishing and characterization if needed. So I have a list of tools and accessories needed for post-processing that I find to be the best so far. I mean, there's always going to be new tools that will come out to help us with this process. But for cleaning, of course, make sure you're wearing safety equipment. Always be wearing gloves, glasses, and aprons when handling this material itself. Using my gloves, you don't want this material to touch your hands. It is toxic when it's in a liquid state. Apron is to protect your clothing. And of course, glasses, when you're removing the sprues, you definitely want to be wearing glasses because you don't want to get poked in the eye with it. Print removal, I recommend using a jeweler's hammer, an X-Acto knife, and with a chisel blade attached to it. The chisel blade with the X-Acto knife allows you to get underneath the printed objects with a high success rate. If you use like a thicker spatula, sometimes you can damage the print when removing it. So I would definitely look into getting the X-Acto knife with a chisel blade. The jeweler's hammer helps in case you need a little extra oomph behind the chisel or behind the X-Acto knife. For the print removal, also we recommend the flush cutter for removing the actual sprues from the printed object. So you want to do this while there's still liquid resin on it. After you remove the sprues from the printed object, whether it's the printed base or the printed teeth or the try-in, you're then going to place it into the ultrasonic cleaner, or sorry, into a cleaning method with alcohol. We recommend an ultrasonic cleaner. There are other cleaning systems out there. I believe Culzer just came out with one, like an alcohol bath system. Of course, Formlabs has one. Also, Carbon has a cleaning alcohol system as well that they use. You don't have to go with anything super fancy though. Just a simple ultrasonic cleaner and 2 Tupperware containers with alcohol works as well. So after the objects are cleaned, of course, you're going to finish off removing the supports, and you're going to use a variable speed handpiece. In the video that we're going to watch here in a moment, it shows them just using some traditional burrs, but I actually found Scotch-Brite abrasive style wheels work the best. With this, it actually smooths off the supports and does not add any extra marring to the surface of the denture, which is going to prevent you, or it's going to eliminate the need of extra finishing during the pumicing and polishing stage. So the Scotch-Brite abrasive pads, I found some last night on Amazon. I think it was like 50 of them for like $20, which is really inexpensive. From here, we're going to move on to the curing and polishing. So the tools and accessories you would need for that, you must use an approved curing unit. Remember, that's Uvatron, Dymax, Electrolyte, Honnold, and then of course also Drave has a curing unit as well that's approved. You're going to need some glycerin. Also with the glycerin, you can use like a Pyrex, a bowl that you put the glycerin in that you'll sink the dentures into. After that, we have a variable speed wet lathe for the pumicing, and I'd recommend starting with medium grit and then moving from there. And then for the polishing part of the denture itself, I would use a variable speed dry lathe. Rag wheel with a traditional denture polishing paste works perfect. So we're going to go ahead and watch these 2 videos real quick. Let's see if it'll work in. It's not want to work on the actual presentation itself. Let me pull up the videos. Here.
Excess liquid on the printing plate with a plastic brush. Be careful to ensure the liquid falls inside the resin tank, as it could otherwise fall in the space between the tank and the printer and damage the lens. Remove the printing plate and, utilizing a metal spatula, separate the printed object from the printing plate. It's important you do so carefully to avoid scratching the printing plate as much as possible. Once separated, cut the supports off the denture base by using clippers. The easiest way to do this is to work your way around the external supports and then carefully breaking the base off to expose the internal supports. Leave the denture bases soaking on isopropyl alcohol for 5 minutes and clean them with a brush and then rinse them with water. Try to remove as much of the printing material residue as possible. The bases should become less sticky as you progress in cleaning them. Repeat the same steps with the teeth, being careful not to damage the teeth as the supports will be very close to the neck. Proceed to leave them on IPA and clean them with a toothbrush and water. Remove any excess supports from the base of the teeth and the denture intaglio with a slow speed handpiece and an acrylic burr. Make sure to pay special attention to the neck of the teeth as they have to connect smoothly into the denture base sockets. Once finished, wash everything one more time with IPA and dry with an air blower, then prepare for bonding. Clean the build plate, ensuring to remove any polymerized material that may be locked between plate walls, and rinse it off with IPA, then dry it up. The better you take care of your plates, the longer their life will be. Place the excess denture base and tooth material to containers that block out light so they can be reused for another print. The material can be reused 2 to 3 times before disposing. It's recommended to filter the material to remove any polymerized residues that may be in the liquid prior to storing and cleaning the resin tank with IPA. Curing and post-curing. Pour some of the base material in a container and apply the same color denture base material to the tooth sockets in the denture base, making sure it's evenly spread as you work through the sockets. Set the teeth over the denture base, then one by one bond them with a curing light for 20 seconds. Make sure to remove any material excess prior to curing. Utilizing the printing liquid and a microbrush, build up the interdental papillas to make the denture more aesthetic and create a continuity effect between the base and the teeth. Repeat the same steps for the rest of the teeth. Once finished with the posterior teeth, make one occlusion check and proceed to bond the anterior teeth. Once finalized, make a final occlusion check and store the remaining material as directed before. For post-curing, submerge the dentures in glycerine. Make sure the dentures stay fully submerged by placing a glass slab on top. Place them in the curing unit for 20 minutes and then, with a set of pliers, flip them around and leave them for another 20 minutes. Be careful when doing this as the glycerine will be hot. Please note curing times may vary depending on your curing unit's brand and model. Once done, wash the dentures. They should look like this.
All right, so that was the first step, showing you how to take the teeth actually off of the base, the print plate, and then showing you how to actually clean the teeth and then lute them together to the denture base, and then of course doing the final cure process. So I do want to show one quick video also. Now both these videos are found on the Dentca website. They have a knowledge center there. If some of these videos actually maybe showed up maybe with a little bit of a lag on your end. So if you want to view the videos again without lag, you just go to dentca.com and locate their knowledge center. Now there's one more video I want to watch. It's only about 1.5 minutes, and it's in regards to the finishing and polishing process.
Finishing and polishing. Once the dentures are done curing, wash them with water and soap, dry them and polish them with pumice and a wet polishing lathe at slow speed. When polishing, make sure to use an abundant amount of pumice and to avoid the tooth areas. More importantly, it's essential to avoid polishing the intaglio surface, as over-polishing these areas might affect retention. If needed, choose smaller plastic discs to clean the intaglio area. If certain areas are difficult to polish, switch to a smaller lathe for better access. This is especially important on the palate area. Once finished, wash the dentures and place them on the ultrasound cleaner for 5 minutes. Then rinse them to remove any pumice residue. Apply polishing paste and polish with a dry lathe at slow speed for a final high shine look. Again, it's very important to avoid the tooth and intaglio areas and to avoid applying too much pressure. This could scratch the denture. When finished, wash your dentures one last time to remove all the paste residue and prepare them for packaging. When finished, your dentures should look like the ones on the picture.
So just like that, you can easily see how simple it is to actually produce the final denture from 3D printing. What he just did is that polishing process and that final output there is a great version, even better than an economy denture. You know, it has excellent characteristics to it and great look to that denture. So I just want to first off also recognize that video once again is provided by Dentca and the doctors over there. So just to recap on this, the step one, you're going to remove the prints from the build plate. You're going to remove the supports. Let me put this back to full screen. You're going to remove the supports from the structures itself, and you're going to smoothen over the support structures where they met either the teeth, the base, or of course, the denture try-in. From there, you're going to bond the teeth in using the actual denture resin itself. So you're just going to use the same color resin that you use for printing the base, and you're going to go ahead and apply some of the resin into the sockets of the base itself, and then press the teeth in. After you press the teeth in, they show using it's like a toothpick-like structure to actually recontour that the resin around the teeth sockets. After that, you'll cure it, and then do your final curing process. Remember, you have to use an approved curing unit with the glycerin, and then you're going to do the polishing and pumicing stage to create the final denture. So if you're doing research on the 3D printed dentures, you're going to see there's a lot of, you'll see some different types where people are actually printing a monolithic denture out of the tooth shade material and then layering on composite for the gum. And then you'll see, of course, the two-piece method, which we just saw, of the teeth and the base being luted together, and they're printed separately. If you were to print it in the monolithic denture, it is an added expense because that is the most expensive resin if you were to use the two-shade material for that. Also, the reason why people say they like to use the monolithic denture over the two-piece denture is that they believe that it's actually stronger than the two-piece denture. That's actually not true. For the actual denture, the two-piece dentures, well, as soon as you lute them, since we're using the same like materials to lute the teeth to the base, it actually becomes equivalent to a monolithic denture. So if anybody has any questions about this, feel free to ask. Now, to take your denture to the next level, let's say you wanted to take that economy denture and actually produce a high quality, high aesthetic denture, there are some characterization options available. So there's three main companies that I wanted to point out. There's Kulzer. They have a Creative, Pala Creative, and Palaseal liquids to actually characterize your denture. Annex Dent has Annex Gum. Annex Dent, the Annex Gum package, to me seemed to be the most complete package available, and we will be demonstrating this Annex Dent, Annex Gum with our hands-on demonstration here at WhipMix. I'm going to go ahead and highlight that here in a moment. And then one of the other companies that I see that has a characterization material is GC with their grade A gum shades. All of these are going to be able to do very similar end results. It's just a matter of what you find best for you and your style. So common questions I get with the 3D printed dentures is, can I reline a 3D printed Dentca denture? The answer is yes. The material, once again, is so close to the conventional acrylic. You can use traditional reline materials for the Dentca dentures. But with that, though, it would almost be less labor intensive just to reprint the denture. So if you still have the file for that patient, it would make actually more sense just to reprint the denture and the teeth and glue them together instead of trying to reline. From here, can I repair a 3D printed Dentca denture? The answer is yes, you can repair the Dentca denture. They have a process for repairing the denture, but once again, it is almost easier and more cost effective just to go ahead and reprint the denture itself. Does the strength compared to a traditional denture? Is awfully similar. Traditional acrylics are going to be a little bit stronger, but is awfully close with the Dentca resins. Once again, the chemical composition is awfully close to the traditional acrylic. Can I use any curing unit I want? The answer is no. You have to use a validated curing unit. Do I have to use the glycerin? The answer is yes, you have to use the glycerin. And can I use any 3D printer I want? The answer is no, you can't use any 3D printer you want. It has to be one of the validated 3D printers from Dentca to be covered under that Class 2 medical device 510K classification. So just to recap real quick, we will be having a second part of this 3D printing digital dentures with Dentca Resins. We're going to have part 2. It's going to be May 21st, 11 a.m. to 12 p.m. With that, we're going to cover 3-shape order form creation, hands-on, so trying and glued in teeth arch form. And then I'm going to go through and design a digital denture. And then I'm going to use the Sega Composer software to go ahead and manipulate and nest and support the structures. From that, I'll cover nesting and support techniques as well. Also, I would like to just go and let everybody aware that there is a digital denture hands-on course that we are going to have here at Whitmix. It's July 25th to the 26th. It is located once again here at Whitmix Corporation in Louisville, Kentucky. It's going to cover topics such as fundamentals of impression taking for digital dentures, 3-shape denture design, 3D printing the Dentca resins with the Asiya 3D printers, and characterizing the printed dentures with annex gum. We will have more information to come here soon, so please be on the lookout if you're really interested. We do have a limited number of spots, and it will fill up fast. And of course, if you have any questions, please let me know. I'm going to go ahead and look in the question box to see what we have. Let's see here. Looks like there are some questions, but it's not that big. Let me see. Let's knock into the panel.
There's one.
Looks like there's one question. So how do you have 3-shape 2019 already? We are a reseller for 3-shape, so we get to beta test the software before it comes out. That is the only question that I have from you guys, so please feel free to reach out to productsupport@whitmix.com if you have any questions, or speak with any of course, our sales reps about the whole process, or even our technical team. We're all well versed with this.
Thanks, Cory. Great job as always. Just want to remind you that we do tape these webinars, and we will have this up on our website most likely tomorrow. It could be about 48 hours from now. Just go to the whitmix.com and our webinar section, and you will see it there. And again, a reminder that if you are a CDT, you will get CDT credit, and that will be sent to you to the email address that you've registered for the webinar, and it'll explain exactly how it's done. I'll just give you a hint. There's a very easy short test that'll be headed your way, and that is about the only thing you have to do, and send it in to us, and we will take care of the rest.
Oh, I do see a couple questions came
Okay.
up. What is the expected lifespan of the printed dentures? I gotta be honest, I do not know that number off the top of my head. It's supposed to be a denture for life. I mean, it's was marketed and tested for the life of a traditional denture. It has to go through all the same qualifications and tests that traditional denture materials have to go through, and so it has to meet that lifespan of a traditional denture.
Was that the last one?
Wait, hang on. How do you recommend? What is my recommendation for a bite registration? So there's a couple systems out there. I really like the Dentca impression tray system that they offer. That is going to capture that bite registration. Ivoclar has a denture bite registration process as well that's very similar to the Dentca tray system. And then beyond that would be you'd have to actually manufacture a wax rim and do a more of a traditional method for capturing that bite using a wax rim and a bite block method.
Okay. Any others? And that was the last one, I believe.
Yeah, I think so.
Yeah.
Yep, that's it.
All right. Well, thank you again for joining us. Don't forget, 2 weeks from today, we have part 2, and we look forward to seeing all of you at that webinar. Have a great day. Thanks.